Hi guys, welcome to Expressions and Equations Lesson C Topic 4. This is an advanced topic where we will be talking about solving multi-step equations with funky fractions. So in this video, we are going to apply inverse operations to isolate the variable and solve multi-step linear equations with funky fractions. We are going to evaluate the equation by substituting the value of the variable to check if the solution is correct. So before we get into the real funky fractions, I do want to just talk about one with you that if you watch the two-step equations, you've actually seen this one before. This is just another way to do this equation because I told you there was many ways to do it. I wanted to show you another way before we got into the real funky fractions. I would not consider this a funky fraction at all. But it is a fraction, and because I ran out of time in the other videos, I thought I'd throw it in here real quick. So if you look at this one, we're going to ask ourselves, is there anything to distribute? No, there's nothing to distribute. There's no like terms to combine, but we do have this constant and we have this fraction that we got to get rid of. So first we're going to look at that constant of positive 12, and we are going to minus the 12 from both sides. When we minus the 12 from both sides, we end up with 2/3 x equals negative 32. And we still have this fraction. Remember, if you watch the two-step equation video, you watch me use the reciprocal and just do this in 2 steps. Multiply both sides by the reciprocal, which was 3/2. But if you just hate the reciprocal way, you can actually do this step twice. Use the inverse of both multiplication and division. So I'll show you how to do that if you end up with a fractional coefficient like this. So the first thing you would do is get rid of the denominator. So the denominator is 3. So we're going to multiply both sides by 3. When we multiply both sides by 3, we get rid of that denominator, and we end up with 2x equals negative 96. So now we have just a coefficient of 2, and so now we're going to divide both sides by 2. And when we divide both sides by 2, we get x is equal to negative 48. And we actually already did check this equation, but we could plug it back in just to verify that 2/3 of x, or 2/3 of negative 48 plus 12, is equal to negative 20. Well, 2/3 of negative 48, remember this denominator, the easy way, if this is divisible by this, I'm going to look and say, okay, how many times is 3 going to negative 48? If it does go into negative 48, and it does, it goes 3 times 16 is 48, so 3 times negative 16 is 48, right? If it does, you can say negative 16 times that top number 2, which is negative 32, plus 12 equals negative 20. And you guys know the fraction stuff because we talked about that in the previous modules. Let's go on to the actual funky fractions. So what does a funky fraction look like? It looks like this, where we don't just have x in the numerator, we have an entire expression. So we're going to ask ourselves, are there any funky fractions? Yes, there's a funky fraction because we have an entire expression in the numerator. So when we have a funky fraction, we have to actually get rid of that denominator as soon as possible. So the only way to work with this and to go any further is to actually multiply by the denominator, both sides by that denominator. When we multiply this side by the denominator, it's important to know that nothing's going to happen to the expression in the numerator because these 5's basically cancel each other out. But this side will multiply. So we're going to have just 4x minus 5 equals 35 now. So now is there anything to distribute? No, there's not. Are there any like terms to combine? No, there are not. Use the inverse of addition or subtraction to undo the constant. It's a two-step equation. So the constant is negative 5, so we're going to add 5 to both sides. When we add 5 to both sides, we get 4x equals 40. So don't forget to isolate the variable by using the inverse of multiplication or division. We have a coefficient, so the coefficient means to multiply. So we have to use the inverse of multiplication, which is division, by dividing both sides by 4. And when we divide both sides by 4, we get that x is equal to 10. So, of course, we need to check our answer. Our original equation was 4x minus 5 all over 5 equals 7. So if we plug the 10 in for the x, we will have 4 times 10 minus 5 all over 5 equals 7. So 40 minus 5, or 35 over 5, is equal to 7. 35 over 5 is equal to 7. 7 equals 7, right? We're correct. Let's go to the next one. Ooh, negative 3x plus 14 divided by 2 minus 9x equals 21. So not only do we have like this funky fraction, but we also have another variable term out here. Well, we're going to just follow the same steps. We're going to ask ourselves, okay, we see a funky fraction. So if we see a funky fraction, we need to go ahead and get rid of that denominator. We're going to multiply everything by the denominator. So the last time we didn't have another term out here that's not over the denominator. But when we multiply everything by the denominator, you have to remember to include this. So let's multiply everything by 2. When we multiply everything by 2, the denominator goes away and the expression negative 3x plus 14 stays. And then negative 9x is multiplied to be negative 18x. And of course 21 times 2, don't forget to do it over here as well, is going to give you 42. So is there anything to distribute now? No, there's nothing to distribute, so we're going to skip that step. Are there any like terms to combine? Actually, yeah, there are. We have negative 3x and negative 18x, which can be combined to make negative 21x. Don't forget to bring down that positive 14. We don't want to forget that, because we still need to solve this two-step equation. And we have a negative 21x plus 14, and we need to get rid of that constant. So it's a positive 14, so we're going to minus 14 from both sides. When we minus 14 from both sides, we are left with the negative 21x equals 28. And this is going to be one of those ugly ones, but we're going to use the inverse of multiplication or division to undo. So we have a coefficient here. Coefficients mean to multiply. So we're going to divide both sides by negative 21. When we divide both sides by negative 21, we get that x is equal to negative 4 over 3. Another ugly solution, but we're going to check this work anyway. So we have negative 3x plus 14 all over 2 minus 9x equals 21. If we plug negative 4/3 in, we will have negative 3 times negative 4/3 plus 14 all over 2 minus 9 times negative 4/3 equals 21. This ends up being 12 over 3, which, guys, that's 4, plus the 14 minus negative 36 over 3, which that's 12. So I'm going to go ahead and put those in terms that it's easy to work with, like 4 plus 14 over 2 plus 12. So 4 plus 14 over 2. 4 plus 14 is 18. Right? Over 2, that's 9. That's where the 9 come from. If you were in, like, what? Where'd that 9 come from? 4 plus 14 is 18. Divided by 2, that's 9, plus that 12. And then we have 21 equals 21. The next, go back to that, see. I guess it didn't make it in there. The 21 equals 21. But it did. So the next fraction we're going to look at, or funky fraction we're going to look at, is negative 2 times x minus 3 all over 2 plus 10x equals 21. So in this situation, we have another one of those situations where we have like what I'm going to call a lone variable. It's out here by itself. It's not with this funky fraction, but we still have to get rid of the funky fraction. We got to get rid of it. So are there any funky fractions? Yes, there are. So we're going to multiply everything by that denominator to get rid of it. So multiply by everything by 2, not just the expression with the fractional expression, but also the 10x and the 21. So negative 2x minus 3 is, we're going to just keep that, plus 20x equals 42. Now we're going to ask ourselves, is there anything to distribute? And there's something to distribute. So we're going to go ahead and do that. Negative 2 times x and negative 2 times negative 3. That leaves us with negative 2x plus 6 plus 20x equals 42. Now, are there any like terms to combine? Yes, there are like terms to combine. The negative 2x and the 20x. We can combine those to get 18x, and please don't forget about your 6, equals 42. So now we have a two-step equation, and we can solve it by looking at our constant. We have a positive 6 constant, and we're going to use the inverse of that positive or addition to undo this. So we're going to minus 6 from both sides. When we minus 6 from both sides, we're left with 18x equals 36. So the last step is to use the inverse of multiplication or division, and because we have a coefficient, we need to divide both sides by that 18 to end up with x is equal to 2. Don't forget to check your work. Negative 2 times x minus 3 over 2 plus 10x is equal to 21. Negative 2 times 2 minus 3 all over 2 plus 10 times 2 is equal to 21. Negative 2 times negative 1, that's positive 2 over 2. It's going to give us 1 plus 20 equals 21. 2 over 2 plus 20 equals 21. 1 plus 20 equals 21. Boy, we definitely did it. 21 equals 21. Let's look at another example. Negative 5x plus 7 divided by 4 minus 9 equals 4. Are there any funky fractions? Yes, there are. But we also have this negative 9. So we need to make sure when we multiply everything by the denominator, including that negative 9 and the 4. So when we multiply this by the denominator, we're just going to be left with negative 5x plus 7. And then negative 9 times 4 is negative 36, and 4 times 4 is 16. So is there anything to distribute? No, there is not anything to distribute. So we're going to skip that step and go to combining like terms. There are some terms we can combine, and they are 7 and negative 36. So we're going to be left with negative 5x minus 29 equals 16. So now we have this two-step equation that we can solve by moving the constant first with the inverse of subtraction, which in this case is addition. And we're going to add 29 to both sides. When we add 29 to both sides, we get negative 5x equals 45. And last but not least, we need to use the inverse of multiplication or division to undo the variable term, and in this case, we need to get rid of the coefficient with division. So divide both sides by negative 5, and 45 divided by negative 5 is negative 9. I want to show you real quick before the video ends another way. Say you absolutely don't really like multiplying everything at first. So you can think, are there any lone constants? And this only works if there's a lone constant. So if this is a variable term, it's not going to work. But are there any lone constants? In this case, there are. You can actually move that constant first if you want to. You can go ahead and add 9 to both sides, and you will have negative 5x plus 7 divided by 4 equals 13. Now you will undo the funky fraction by multiplying by the denominator, both sides by that denominator, to get negative 5x plus 7 equals 52. So it looks like a different equation here, but it's really the same thing. We're going to, again, is there anything to distribute? No. Is there any like terms? No. But we do need to go ahead and solve the equation by minusing 7 from both sides to get negative 5x equals 45. And then we need to use the inverse of multiplication, because coefficients mean to multiply, by dividing both sides by negative 5. And we get x is equal to negative 9. We do need to check the answer by plugging our negative 9 into the original equation. And once you check the answer, you will see that negative 9 is correct because 4 does equal 4. Thank you for watching the video, and I hope this helps you understand funky fractions.